when you finally understand what containers are. Remember the days where applications will fail to run correctly, for example, between your laptop and the cloud provider? Maybe that's something you're even seeing today in your current job. Such problems typically arise due to differences in configuration between the underlying library requirements and other dependencies. Now you're moving to microservices, but you have to figure out how to package these dozens, if not hundreds of services and deploy them at scale across your organization. That's where containers come in. Each microservice will be deployed in a container so they can be deployed and scaled independently without any impact to the rest of your system. So what are containers? No, we're not talking about shipping containers. Containers are lightweight packages that bring your application together with its libraries, dependencies, and configuration settings required to enable them to run quickly and reliably anywhere. Docker created the industry standard for containers so they could be portable and run anywhere. Containers are lightweight because containers share the machine's operating system kernel, and they don't require an operating system per application. That's driving higher server efficiency, but also reducing your server and licensing costs. Containers enable you to separate responsibility because they provide a clear separation between developers focusing on application logic and dependencies and operation teams that can focus on deployment and management instead of application details such as specific versions and configurations. So what are the containers' benefits? Well, first we talked about portability and being platform agnostic. Build it once, run it anywhere. From clouds to on-premise to edge, even jets for us in DoD. We have 1,000 containers in the Department of Defense just based on open source and commercial software that we can run anywhere from classified clouds to the edge, to jets, to bombers, to space systems, all the way to nuclear systems as well. The second benefit is adaptability. Containers are Lego blocks. They can be swapped with no downtime thanks to modern load balancing and modern routing, A/B testing, canary releases. That enables you to reuse capabilities across teams like Lego blocks. Check out our video, SpaceX versus F-35, to see the impact of that kind of capability. Another benefit is speed. You can start, create, replicate, or even destroy containers in seconds. That gives you immense and smooth scaling. You're also getting performance and operational simplicity. Because containers are so lightweight and easy to run across platforms, you're now streamlining the entire process to orchestrate your entire system. Containers also gives you application isolation. Containers virtualize CPU, memory, storage, and network resources at the operating system level. That provides developers with a view of the operating system logically isolated from other applications, increasing your cybersecurity. Finally, containers are immutable. That gives you the ability as an organization to centrally accredit, harden, and update open source, commercial, and your custom software as well. So what is really the difference between containers and virtual machine? Well, containers are often compared to virtual machine, but really they're completely different. Containers use a concept of layers, so they can inherit the hardening that you do from the base image. For example, you could have an operating system hardened as a container image. On top of that, you could bring a Java container, bringing OpenJDK that you're going to harden as well. And your application is going to use the Java base image that it will already be hardened, but also have the hardening of the operating system base image as well. So you can build layers of containers of hardening, and when you update one of the layers, all of your other containers will update seamlessly as well. You're streamlining your patch management process across your entire enterprise. Like virtual machines, containers allow you to package your application together with libraries and other dependencies, but that's it. The benefits of containers are so vast. First, of course, we talked about the fact that they're so much more lightweight than virtual machine. Containers virtualize at the OS level versus virtual machine that virtualize at the hardware level. And then, of course, containers share the OS kernel and use a fraction of the memory that a virtual machine will require. There you have it. By leveraging containers, you decouple your development teams and streamline your ability to operate at a broader scale. Your complex systems will turn into Lego blocks which will become reusable and shareable across teams and projects. This is how large organizations can scale to billions of users. From Gmail to YouTube to search, everything at Google runs in containers. Containerization allows their development teams to move fast and deploy software efficiently and operate at an unprecedented scale. You too want to also take advantage of all these benefits.